For question 13, it's to simplify 1 plus tan squared theta over cosecant squared theta plus sine squared theta plus 1 over secant squared theta. Now, in order to do this, we need a couple of trigonometric identities. First, let's go over them. So we have tan theta is equal to sine theta over cosine theta. This stems from the trigonometric functions on a right triangle. Sine theta with a angle theta. Sine theta will always equal to the opposite side over the hypotenuse. Cosine theta will always equal to the adjacent side over the hypotenuse. And tan theta will always equal to the opposite side over the adjacent side. Now, if we take sine theta over cosine theta, we can see opposite over hypotenuse over adjacent over hypotenuse, which then simplifies out to opposite over adjacent, which is again equal to tan theta. Therefore, sine theta over cosine theta is equal to tan theta. Now, there are three other trigonometric identities. Cotangent theta, which is adjacent over opposite, secant theta, which is hypotenuse over adjacent, and cosecant theta, which is hypotenuse over opposite. Notice anything? These three are reciprocals of these three: cotangent to tan, secant to cosine, and cosecant to sine. Thus, we can see that secant is equal to 1 over cosine theta, and cosecant is equal to 1 over sine theta. Now for the Pythagorean identities. First, in a unit circle where the radius is 1 unit, if you take any terminal ray and you take the height and width of that ray, the height will always be sine theta and the width will always equal to cosine theta. This is what's special about a unit circle. Now, if we take the Pythagorean equation, a squared plus b squared equals c squared, then we can see sine squared theta plus cosine squared theta is equal to 1 squared, the hypotenuse squared, which is equal to 1. Therefore, 1 equals sine squared theta plus cosine squared theta. Now, if we divide both sides by cosine squared theta, we can see 1 over cosine squared theta is equal to secant squared theta by the reciprocal. Sine squared theta over cosine squared theta by this quotient is equal to tan squared theta, and cosine squared theta over cosine squared theta is equal to 1. Therefore, tan squared theta plus 1 is equal to secant theta. Now, back to the problem. In this problem, first thing we're going to do is try and simplify using this Pythagorean identity. See, 1 plus tan squared theta we know is equal to secant squared theta. So it becomes secant squared theta over cosecant squared theta plus sine squared theta plus 1 over secant squared theta. Now we want to put this into terms of cosine and sine. Secant squared theta, remember, is the reciprocal for cosine theta, and cosecant theta is the reciprocal for sine theta. So this becomes 1 over cosine theta, 1 over cosine squared theta over 1 over sine squared theta, plus sine squared theta plus 1 over cosine squared theta. Now we can simplify this into sine squared theta over cosine squared theta plus sine squared theta plus cosine squared theta. Then we can use the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, to make this into sine squared theta over cosine squared theta plus 1, and then we can use this quotient identity to turn this back into tan squared theta. So tan squared theta plus 1. And finally, we use our second Pythagorean identity again to make this into secant squared theta. And that is our answer.